So in the version controlling, or we also call it a software configuration management, the tool that we are going to look and we are going to understand and work around practically is Git. Before we get into Git, first of all, let's have an understanding on what is software configuration management. Okay. And even before getting into what is software configuration management, first let's understand why do we need this and where does it fit as part of an organization and where does it fit as part of the operations group or the administration group. So now, if you take any software development lifecycle, the developers are the beginners who are going to write code and get the tasks to beginning. That's what they will be writing the code, right? So let's focus only on that for a time. So when we have these group of developers who are writing code, it is not just one group who will be working on the product. There might be many group of people who are working on the same product. And the developers can be in the same region or they can be distributed across the globe. That is when you will have a person working from India, you'll have a person from working from US, or you could have a person working from UK or pretty much anywhere else. So that is when what will happen is, first thing is, when a developer is writing a code, he has to share it with his peers across the globe to make sure that whatever changes that he has done is being picked up by the other person and they are collaboratively working. What will happen at this point of time is there'll be a lot of coordination problem where you do some change and your peer is also going to do the same change on the same file, and at the end when you want to give it to the QA, which change will you give? How will you integrate both these things? So that is when there's a lot of complexity that's going to happen. The same thing now, if you are dependent on someone else's task, how will you know whether he has done it? In case if he forgot to send you a mail or notify, then you have to keep waiting until the changes is done. So that is when you have a dependency in such a way of working in the development, then we need some process to be followed. Next, let's talk about process, where in a company, you need a code. Sometimes you need to use it as part of your product and get some functionality, which could be a common code, or you could just use it as a feature without doing any development. So that is when you should be able to allow people to do the changes, and we should be able to allow people only to see the changes but not to modify anything in the code. So that way, how is that you're going to ensure all this process oriented approach and permissions? And coming back to the last and the major problem, when you are working as a developer, you are not going to write one file. For example, you are trying to use Java for doing the development. What will happen? Now you will have to write many Java files to get the actual functionality of a product. So that is how, if you look a product might contain thousands of Java files and thousands of other related files. So when a developer is trying to write a file, he will not be just writing a file in one day. Depending on the criticality of the task and how long the product is going to take, you might have to take several days and several modifications that you will be doing on the same file. Now, what will happen if you are trying to do the changes on top of changes for the same set of file? At some point of time, if you want to refer anything what you have done, it will not going to be easy for you. So what is that you're going to do? You are going to take a backup and keep tracking everything. So that is when it is not easy, where if you want to know that what is the changes that you did last week, you don't know because you are doing changes on top of that. And if you literally want to take a backup of each and everything, it will not be available. And are you going to store everything in your machine? For one file, if you have modified it 100 times in 10 days, you're going to keep 100 files as a backup, so that you will know for this time this change you did and this time this file you changed. Like that you cannot keep. Now the same thing, if you have 1,000 files in your product, how is that you're going to maintain? The same thing, if you have 100 developers working on this 1,000 files 100 times, then how many backups they are going to take, right? It is not an easy to track everything. So that's when the most important thing that we need is, whenever we are working on such a kind of development activity, we need a process where that kind of process which will help us to properly track who is doing a change, when he did the change, what he's done the change, and we can store everything in a proper place where we can have a control on who should access and who should not access. So such a kind of process which a company is going to implement for the development and storing the changes is what we call it as a software configuration management. Okay, or it is also called as version controlling. Why it is, we'll talk about it a little later, but for now understand, software configuration management is a process using which we will be making sure all the code that we are writing will be stored and it will be effectively tracked, so that any point of time, no matter how many users are working, we can clearly say this user modified this file in this line at this point of time. And same thing, who should access and who should not access can be clearly classified. So that's when the goal from the SEM process is to ensure teamwork, track any kind of problem that you have easily, because now when you have too many developers doing the same change, it is very difficult for us, right? As a DevOps, you're going to focus how quickly you're going to find out a problem, so that you can do it using SEM. And if you need it for auditing purpose, you can easily track on who did it, when he did, what and all they have done. And also ensure a process is followed, so that who is going to do the change and who is not supposed to do the change. Okay, so all those things can be tracked very easily using software configuration management. There might be a question that might be coming to you as, okay, what you're talking is about the developer. How is that as a DevOps engineer, I am going to do all these things? I'm a developer, no, but we are going to assess the tool, whatever that we are going to use for it. We are going to define the process on how the development should be working. And coming to the other important point is, it is not only the source code or the Java code or whatever code you are using for creating the project should be stored. Pretty much now at this level of the culture in IT, everyone has to do some kind of scripting or coding or documentation which is needed for automation, right? So that is when, being a QA engineer, you should have been writing some automation scripts. By a developer, other than let's say you are a build engineer, you are trying to write some build scripts. You are a system admin, you are going to write some automation scripts for your maintenance. So like that, everyone is going to write some kind of script. May not be a program, but a script or a documentation. How is that you're going to store all those things? So pretty much any text related files that you want to store and maintain, everyone will be using software configuration management. So it is not just a developer. The SEM is going to play an important role in almost all the areas where you have automation. So that is when everyone, including developers, QA and build engineers, program managers, documentation engineers, IT engineers or administrators, everyone will be using software configuration management. So that is when it is quite important for us to come into the DevOps culture where we will be effectively managing the process and taking care of the tool. Okay, so that's the important thing. So that way, now let's talk about one more thing before we get into the history. So there are certain common terminologies that you should be aware of, because sometimes if you go to an organization, you will also be working on some older tool that we have in the market for SEM, because in the SEM, one of the tool that most popularly used in the market is Git, because of a couple of reasons that we will talk. But we also have many other tools like Subversion, Perforce, or ClearCase. So what is the advantage of all those things? Now that is independent of each one of them. But the focus, what we need to know is, there are certain common terminologies that we will be using in SEM, that the same thing we will also be using in Git. So that first let's understand it and then jump on to the actual Git. Okay. So to understand, let me walk you guys through some diagrams so that it'll be more easy for understanding. So when you talk about a SEM system or a tool, basically how you implement a process, you will use a tool for it. Okay. Now I'm not talking about Git, but I'm talking about a generic tool, any kind of tool that you're looking into the market. This is how it will be working. So primarily, when you take any tool, it will be having a server and a client model. What do you mean by a server and a client is, you will be having a server software where you will be storing everything. Whereas you will be having one more thing called as client, which we will be accessing it from our laptop or from our machine. Okay, so you can consider that as the client, and whatever that you are going to store and maintain, we are going to call it as a server. Okay, so now let's take that for your SEM tool, you are having a server where you are maintaining everything. So what is it going to do? This is the server where for each product, whatever files that you are going to write, you are going to put inside it and store it. Okay. How you are going to store, that is what we are going to learn in the practicals later. But here, focus on the concept on what is the terminology. So now in the server, I'm going to put all the files related to all the products that we are maintaining. That way, the same server will be having various products that we are going to work in the company. So let's say your company has 3 products, A, B, C. Now, if you're going to use the same server, you're going to put all the files related to product A, related to product B, and related to product C inside it, right? Then it will be confusing for us to maintain. So that is when what we are going to do is basically we are not going to dump everything directly, but inside this we are going to create something called as container. Okay, so what do you mean by a container? Container is nothing but a place where you store something. Same way, inside our server we will be actually creating a container which is called as repository. Okay, where a repository is nothing but a place inside your server where you will be storing and maintaining all the files related to one product. So like this, for each product, you will be having one container or repository in which you will be trying to store all the changes related to that product. Okay, so now I can have a repository A and I can have one more repository called B, where this is the one where I'm going to store all the files related to this product. Same way, I can have one more repository where I can store all the files related to this product. So that way, a repository is a place in your server where you're going to store all the files related to that particular product. Okay, now you can have as many repositories as you want depending on how many products that you're going to work on. Okay, now here if you get into a repository, in this, as I said, all the files related to that particular product will be available in this. So if you have these 2 files for your product A, then it will be available. So anything that you do here will be known only to this. Same way here, if you have some file, now anything that you're going to do inside this is known only to this repository because it is a closed environment where you're going to store all the files related to only that product. So that's why even though you can see the same name, both are not same. This is something similar to only this product, and anything that you're going to store is known only to this repository or this product. Like this, you will be having many repositories where you actually store all the files. Okay, now this is where you are going to store. But now as a user, what is that we are going to do? So that is when on our machine or our laptop, wherever that we are going to work, first thing what we will do is we will create something called as workspace. So a workspace is nothing but a directory where I will be trying to work on the files of a particular repository. Now, let's say that you are interested to work on product A. So to work on the product A, you need all the files to be visible on your laptop. So that is when you are working on SEM, you will create something called as a workspace, which is actually a directory. Directory means a folder in which you will be able to see the files corresponding to a particular repository, and this is the place where you will be doing all the changes. So it is nothing but a directory in your machine. But how is it on your machine when you have a directory? you are going to get the files from your server. So that is when we will be using the client. Okay, so you will have the software called as client, which will help us to interact between the server and your machine, so that anything that you want from this machine, you will tell it so that it will get it from the server. The same thing, that anything that you want to do from the server, you will be interacting. So the interaction between the server and the user's directory or workspace is going to happen through client. Okay, now you are interested to work on the product A. That means you should be able to see the files of the product A and do the changes. So that step where you will be trying to get the copy of the file from a repository inside your workspace, so that this is where you will be actually modifying the files, not in here. Like this, every user will create his own workspace, and in that workspace, he'll be trying to get a copy of the repository where he will be able to see the files and do the changes. Okay, so this step where from the server, you are taking a copy of the file and putting inside your directory or workspace is what we call it as checkout. So checkout is the process where you will be able to see the files inside your workspace on your machine corresponding to a particular repository. Like this, if you want to work on product B or repository B, you will create one more workspace, and in that you will do a checkout so that the files corresponding to this repository will be available in that particular workspace. Okay, so the first thing that you will do is create a workspace, and in that do a checkout based on a particular repository, and from that you will be able to see the files. Then in this, you will modify this file as a developer, and once the changes has been done, you have to store it back to the repository. So that process where you tell to the server that these are the changes that you have done and you want to store it back to the repository is what we call it as check-in. Okay, so checkout means you will be able to see the files, do the modification, and do the check-in where you will store the files back to the repository. So like this, each user will do a checkout in his workspace and do a check-in. Corresponding to that, it will be trying to store all the information. So how is that it is going to store? So for every check-in that a user does, pretty much, it is going to create a reference in the corresponding repository. Now, if you see, you are working on the repository A here. So if you do a check-in, it will be trying to store a commit or a reference here. Okay, before that, let me tell you in this way. So it is going to create a reference. So like this, for each developer who is going to do a check-in, it is going to put a reference inside the corresponding repository. Suppose you are working on this repository. If you do a check-in from your workspace, it will be creating a reference here. So like this, for each user, when he does a check-in, a reference will be created. And this is the reference which will be having all the details about who is the person who did the check-in. In that check-in, what files he modified, when did he modify it, and what and all he modified, and how many files he has modified. Everything will be stored in this particular reference. Okay, that is how we will be tracking on who changed it, what changed, when did he change, and what all he changed. So everything will be referred. This way, for each of the repository, there will be specific references which is created. Okay, and now these references that you are going to have will be individual, or it will be with respect to only that repository. This repository doesn't know anything about this because it is stored only for this files. Same way, anything that you store here is known only to this. So these references that we are going to store in each repository is what we call it as a version. Okay, so a version is nothing but a unique identification as a reference which we will be using to track who changed, what changed, and how and when it was done. So all those information, we will be storing it inside the repository. So getting it? So this is what you will be doing practically when you're working. So you will be having a server in which you're going to store a repository where all the files related to one product you are going to store in it. And in that, if a user wants to work, he will create a workspace, and in that workspace, it is nothing but a directory. He will do a checkout with respect to a product repository. He'll be able to see the files, do the modifications, and do the changes, and do the check-in where it will store it as a reference, where each reference is called as version. Okay, that is why the tool, or the software configuration tool, is also called as version controlling tool, because this is the one using which we are going to maintain and track everything. That is why it is also called as version controlling system or tool.